Okay, last is confidence interval and hypothesis test for one proportion. We did spend a couple days on two proportions. They are not being covered by this take-home exam thing. So the whole idea here is there was some proportion or some probability that we don't know. We would like to know it. The way we're going to try to figure out what it is by collecting a sample. We sort of test as many as we can, run the test over and over, or check like a bunch of examples and see how often the thing we're looking for happens. And based on that data, we could either find a confidence interval, which is a range of numbers where we think that the true proportion is. We know what the proportion of successes was in our sample. We can turn that into a guess of where the proportion might be for everything. Or we could run a hypothesis test and say, well, there's a specific proportion that either I want to compare myself to, or it's supposedly the right answer, and I want to check if that's true. So either it's supposedly the right answer, I want to check if it's true, or it's just a number I'm comparing it to, and I want to know if I have something different. And then I run a hypothesis test, and then I can get a conclusion to see if it's the number I'm comparing to, or if it's something different. So let's just run through one example. This was recently we did these. So example, a manufacturer receives a shipment of 100,000 computer chips. The supplier guarantees that fewer than 5,000 will be defective. Okay, so I mean, 5,000 out of 100,000, that's quite a bit, but I pulled this question out of the textbook, and that was the numbers they had. So I guess what I mean by guarantees is if there's more defective than that, then the supplier might, issue a refund or send more or something like that. So that's what I mean by guarantee. So we want an idea of whether or not this is true. So we take a sample. We don't want to check all 100,000 chips right away. We want an idea of how good this shipment was before we start, actually using the chips. So we take a random sample of 200 of the chips, and the random sample of 200 shows 8 defective. Okay, so out of this batch of 100,000, we grabbed 200, tested them. 192 of them were fine, 8 of them were defective. So first, let's run a hypothesis test. Then we'll find a 95% confidence interval. Okay. So I guess I should have a testing level for my hypothesis test. Let's test at 5%. So remember that with hypothesis tests, you generate a p-value, and if p is less than some specific line, then you're going to say we have strong evidence that the null hypothesis is wrong. And so 5% is going to be our line. For the hypothesis test, we need a null hypothesis, which is the established number or the number we're comparing it to. And I guess that's the supplier guarantee, right? We want to know where we stand compared to that 5,000. So 5,000 out of 100, that is 5%. So that's 0.4. It was that's a proportion. 5,000 out of 100,000. That's 0.05. Okay. So that's the number we're testing against. We want to know, is the number of defective chips less than that? So that's sort of like the line we're testing against, what we're comparing ourselves to. And the null hypothesis is always sort of a specific number that you're comparing yourself to. Our alternative hypothesis should be not a different number, it should be how we compare to that. So the default alternative hypothesis is not equals. So P not equals 0.05. That's our default. And unless we have a really good reason, I tend to just use not equals. But we could use, okay, so we could use P less than 0.05 because we want to know if we have less than 5,000 defective. That would be good. Or I suppose you could just you could probably make an argument for using P greater than 0.05, and then you say like, well, if it's greater than, then the shipment is bad and we should demand a refund. So this is the same as, is the shipment good? Or I suppose we could make an argument for making the alternative hypothesis P greater than 0.05, which is a way of saying, is the shipment bad? Now, which of these we will use? Well, I'm going to go with the default one, which is not equals. Picking this like less than or greater than, like usually just like makes things confusing. The safe thing is just use not equals and say, okay, are there 5,000 bad ones? Maybe. If it's not 5,000, then you just sort of look at what ratio we actually had. If it's not 5,000, it's either not 5,000 because it's low, and that's good, or it's not 5,000 because it's too high, and that would mean there's too many defective ones, and that's bad. So I'm going to use not equals for my alternative hypothesis. So let's run this all over to Minitab and see what we get. So this is under stat, basic statistics, one proportion. I have the summarized data. 8 out of 200 were defective in our trial. We want to perform a hypothesis test, and the hypothesized proportion, the number we're comparing ourselves to, is 5,000 divided by 100,000. That's the proportion that is sort of the dividing line that we're testing against. So that's 0.05. Okay, so we go over to options. I am using not equals for my alternative hypothesis. Like I said, we could have made an argument for either of these, but I'm going with not equals. And I've been using the exact method because why approximate when the computer can do the exact? It's just better. This is going to give us the confidence interval also, which is the second half of the question. So may as well get both of our answers in one step. Hit OK, see what we get. All right, so our p-value came out to 0.531. So what does that mean? Well, it means that maybe there was 5,000 bad ones. Okay, or I suppose maybe it could be more than that. You know, so like we have this isn't small enough for us to say it's not 5% of the chips are bad. We would have liked to have said it's not 5% of the chips that are bad, it's fewer. But this p-value is too big. We don't have strong evidence the null hypothesis fault is wrong. As far as we know, 5% of the chips are bad. That's 5,000 out of 100,000. Could be more, could be less. And speaking of could be more, could be less, we look up at our confidence interval. It could be as few as like 1.7% of the chips are bad, or it could be as high as 7.7% of the chips are bad. So based on our sample of 200, we don't know. This might be a good batch. It might be a bad batch. If we wanted to know which one it was, we'd just have to check more chips. 200 wasn't enough. So maybe we have to check 1,000 chips. Maybe we just have to start building things and see how many are bad as we're going along. Basically, the results of our little test of 200 were not particularly helpful. Now, if the point of testing those 200 was to know if it was a good batch or a bad batch, we don't know. It could be like a 2%, a good batch because only 2% of the chips are bad, or it could be a bad batch because like 7 or 8% of the chips are bad. So inconclusive, that is our answer to this question. Okay, so those are the sections that are covered on the test thing that's going to be this weekend. And I'm going to post sort of the practice version on the website. That is not the real test, just a practice version that I will go over in my videos tomorrow and Wednesday. And that I'm going to make tomorrow and Wednesday. I guess they'll be labeled as Thursday's videos. And then on Thursday, I'll make the actual test project thing that will be graded and count for your points. Okay, so that's enough for today, I think. And I will see you in a couple days.